Good morning, good afternoon, good evening, wherever you're joining the BIM Africa Because Innovation Matters virtual conference from. I'll be making a presentation on BIM for information management in the construction industry. My name is Opeoluwa, Akinradewo. I'm a probational member of the Nigerian Institute of Quantity Surveyors with 3 years experience in the Nigerian construction industry before moving to South Africa to further my education. I'm also a registered member of the Association of South African Quantity Surveyors. I did my first degree and a master's degree in quantity surveying, and my research focus used to be on cost effectiveness of construction projects to achieve value for money. However, I've developed interest in lean construction and construction automation over the years with my recent research focus on blockchain technology adoption in the construction industry. Presently, I am a graduate researcher at the CIDB Center of Excellence at the University of Johannesburg, while I'm doing my PhD program in the university's Department of Construction Management. And I work also as a teaching assistant in the department. I acknowledge the mentorship of my supervisors, Professor Clinton Aibavo and Dr. Ayodeji Oke. And I also acknowledge D. Lee, JPAC, and S. Song for their BIM-based information management research that was carried out in 2018, on which my own research for this presentation was based on. For this presentation, I'll be making my discussion based on the following breakdown of table of contents. I'm starting with the introduction, and then I'll give an overview of information management in the construction industry before giving a little breakdown of the information management challenges experienced in the construction industry. Then I'll give a discussion on BIM and information management incorporation before giving us a case study of BIM-based information management tools. Then we have the conclusion aspect. By introduction, information is defined as data endowed with relevance and purpose by Drucker in 2007. This is because information is derived from the interpretation and understanding of data contextually. Decisions, emotions, expertise, judgments, and knowledge are expressed through information by individuals. And therefore, information can be said to be a converted data, which certain users find usable due to its value. Generally, information as used in everyday English has been adjudged to be very important in any contemporary society. With that being said, there is a need to manage information for day-to-day usage. This is because information technology is gaining more grounds globally, even though knowledge and its communication are the basic characteristics that improve every society inhabited by humans. So based on the foregoing, it can be put forward that information serves as an entity for communication to be achieved between individuals to ensure an action is taken by the receiver of the information. Over the years in the construction industry, information has been shared and communicated through various means. We started with the courier papers or mails, which is being sent through the post office or courier services. Then gradually we graduated to diskettes, the floppy disks, and then we moved to fax machines, after which the CD and DVD were used to share information among construction professionals. Then later we have the flash drives and hard drives, which are then used to store data, to store information, and then shared among construction professionals. But presently we are at the internet age where we save information, we save data on the cloud, and then a link is just shared between construction professionals to collaborate on the necessary data or information that is being shared. Typically, in the construction industry, this information needs to be managed, and this can be done by applying intelligent management principles, which include planning the information management process, organizing the information into different categories, as well as development of control over data and information to ensure there is a clear line of access and usage to information in a particular database. For a typical information system, we have different characteristics that makes up the system and ensures effective data or information management. This information management can be achieved through integrating people, software, technology, and hardware, such that this will assist the conversion of collected data into information through proper communication while using adequate networking system. This can thus help in utilizing the information ethically in decision making for goal achievement in an organization or the construction industry at large. Information management in the construction industry has shown that different types or different categories of information are being used in the industry. We have the figured and non-figured information, and we also have the structural and non-structural information. All these are expressed in a form that can be referred to as documents. This information comes in document forms, and they are being shared among professionals as well as stakeholders in the construction industry. This figured and non-figured information include the ones shown in this chart, but they are not limited to this. We have the design and drawings. We have a bill of quantities, specifications, program of work, schedules, site reports, approvals, progress pictures, and then we have the invoices or will bills, among other information that are gathered on sites. So to effectively have a suitable information management system, all this information must be incorporated into a single database, from which the information can then be managed and shared among the construction stakeholders. The various challenges that are facing the construction industry today that has served as a barrier to a proper and effective information management are discussed in this slide. Information in the construction industry is very, very significant, as it is the document shared among project stakeholders from inception to completion in order to achieve the client's objective. So as stated earlier, this information comes in form of documents, and there are various stakeholders involved in a given construction project, as well as there are different phases to be embarked upon in order to achieve the project. These have led to the fragmentation of the industry based on the reality that we have different stakeholders, different professionals who come together to work on a singular project. This fragmentation of the industry has equally resulted in complexity in the document management system, which caused by having difficulty in tracking, in securing, in retrieving, and also in the control of information that are being shared among the construction professionals. As there is increase in the production of documents and its distribution channel in the industry, there has been a challenge of information fragmentation, non-accessibility, possible loss of information, as well as non-traceability of this information being shared. Also, document mismanagement and ineffective retrieval system has made information processing and communication difficult. And this can lead to dispute among the project team. Therefore, for productivity to be increased in the construction industry, there is a need for a drive to make information management more efficient. Introducing building information modeling into the information management system shows that over the years, there have been different electronic document management platforms that has been introduced as a viable information management system. Among these are the CIC, which is a computer integrated construction, the continuous acquisition and life cycle support. Then we have the project management information system, among others. However, the construction industry works with non-figure and figured information, which the existing databases cannot adequately manage consecutively. So recently, building information modeling is taking central stage in different electronic formats, as it gives room for collaboration using an open BIM server. This shows that BIM exists to resolve the problem associated with all the other construction information management techniques. And it can be said that BIM is a technique that uses a three-dimensional parametric modeling technique to consolidate the information generated during the construction phase. Although presently we have more than the 3D BIM, we have the 4D, the 5D, even up to the 7D. So it is not, these BIM tools are not being used enough for construction information management, though the consolidation of construction information and database is very, very efficient if being incorporated into the BIM server. This may be attributed to the insufficiency of database system for BIM and the lack of means to effectively link figure information and non-figure information. However, there are different softwares that are being generated or being designed by different organizations, which has been able to incorporate all the different formats of information that are being generated in the construction industry, be it the figured and non-figured information, or be it the structural or non-structural information. This information are incorporated into a single platform from which APIs are developed to read the different formats of the documents or information, and then proper and effective construction information management is being carried out. A typical example of this is the Forge software by Autodesk, which is a system that is developed to manage the different forms of information that are being generated to ensure collaboration among professionals or stakeholders in the construction industry. This will be shown in a short video in the next slide here for proper understanding.
Forge is Autodesk's cloud development platform. The Forge platform is a set of web service APIs that you can use to build innovative cloud-powered applications. Forge APIs help you tap into your design and engineering data, which means you can streamline and innovate how you work. Whether you want to build solutions that automate processes, connect teams and workflows, or visualize your data, the Forge platform can help you do that, and so much more. Today, companies are using Forge to build digital twins, visualize and analyze data, render photos to 3D, integrate AR and VR, create product catalogs and configurators, automate design processes, and integrate SaaS products. Forge empowers developers and innovators from concept to completion. People across industries and companies of all sizes use Forge to unlock their data, improve collaboration, and build new services to address today's connected customer.
All right, yeah. From the video shown, it can be said that effective accumulation and management of documented information at a construction site will exert a significant influence on efficiently progressing construction. And also this will assist in understanding the technical know-how of the construction process. To adequately understand how the BIM-based information management system works, a study by Lee, Park, and Song in 2018 will be used to explain the database framework, as well as the interlink between the different stages of using BIM-based information management system. The overall structure of such BIM-based construction database is depicted in this figure here, such that The information that have been generated on site during the construction phase is represented in the section A. This framework is showing us a situation whereby information has been generated, the 3D designs have been generated already, but now we want to incorporate site information that are being gathered day by day on construction sites into the BIM models that has been designed for proper information management. So in section A, we have the data which is being collected daily on construction sites. These information are prepared by the individual professionals who are in charge of the different activities. So having collected the data in section A, the data is now structured and rearranged in section B. This rearrangement and categorization is done using a pre-designed categorization system, which can be referred to as a breakdown structure, as shown in this section B. So having categorized the data into the different sections, then we have the database in section C, where the information is being stored. The usage of the information that has been broken down using the breakdown structure is apportioning a particular classification code to individual information, such as the document title, the dates, or other characteristics of the individual data that is being stored on the site information database. Then with the data stored in the database, it can be retrieved at any time for analysis or used to compare new or future projects to be constructed. However, this is just the first phase of the information management. However, in section D, we see the interlinking of the stored information with the different components of the BIM model, such that individual member or individual object in the BIM model is assigned the information that is being gathered on that particular object daily on the construction site. So with the interlink now, this allows the information for individual section or individual object to be retrieved and used for construction management, either by the construction manager or the stakeholders on that particular project. And this information also can be used for future projects. So to make it more understanding, I would break it down into the different phases, and then we can have a discussion over them. What we have here is the breakdown of this section A, this section B, and then this section C. Here in section A, we are working with a typical information that is being gathered on construction sites. There are different documents that can be generated in section A based on the particular project at hand. And these documents are mostly basic reports of activities, such as the daily work reports, minutes of meetings, variation claims or variation approvals, among other information or other documents that are being generated on site. So basically, this document is therefore having generated the daily work reports as we'll be using in this example. The information is now taken into the section B, where it is broken down into the different structures that makes up the whole document. So for this example, we'll be using 3 different categories of classification. That is the information breakdown structure, the space breakdown structure, as well as the work breakdown structure. So here we can see that the daily work report is the document information. If it's a minute of meeting, that becomes the document information. At a glance, we'll be able to see and understand that, okay, this is what this particular document represents. So that gives us the document information, and it is classified under the information breakdown structure. for the space breakdown structure, we are looking at the project information, the general information, and then the location information, such that for this particular document, here we have the project name, we can have the client name, we can have the all the stakeholders that are involved categorized under the project information. Then we have the general information, which is mostly generic for all the reports or all the documents that are being generated on a construction site from day-to-day activities. So here we have the date, the month, the particular year, and then we have the weather condition for that particular day, the temperature, and every other generic information that can be gathered for that particular document. So now we'll move forward to the location information. Location information will inform us which particular object is being worked on and where is that object located on the construction site. So for this example, we have the first item, which is carried out at the parking lot. Then we have the one at the pit floor, the one at the parking lot also. So then we have the work breakdown structure, which gives us the work information that is being done on that particular day when this daily work report was generated. So from the information we have here, we can see the common construction that was carried out at the parking lot to install a safety device. Then we have the concrete works also that were done to install concrete forms at the pit floor. Then we install concrete forms also at the parking lot, as well as rebar assembly, reinforcement work arrangements at the parking lot. So this information we have here has been classified as our work information. So individual information that has been generated here would be assigned a particular classification code. The document info is given the code A800 to B600. This is dependent on the individual carrying out the information classification. So then for the other ones, we have a particular code, the project code. We have P010/00, depending on the designer's discretion anyway. So you can assign code based on how you understand or how you want the information to be classified. Because basically on the database, you will be needing the classification code to retrieve any information at any particular point in time. So you do the same thing also for the work breakdown structure here. The general requirements, the safe railing installation, the concrete installation, and every other thing. So individual item of work that is being carried out, the location where it is being carried out, the general information of that particular day, and the project name and the document information would be assigned individual classification code to make it easier to understand and to retrieve this information. Then this is our section B, as we have explained earlier, and here we have the section C. What we have here now shows us how the information that was gathered is being represented on the database. However, the stored information can be saved in either the categorized documents, categorized documented information format, or in an electronic document format. But it is always advisable to have both formats stored on the database, because the electronic document formats will give room for accumulation of non-standard documented information. And this offers a solution to the problem that may arise should there be a destruction or loss of the documented information or manipulation of the documented information. What I mean by the documented information is what we have extracted out here at this particular level. We already, from the information that was gathered on site, we've been able to classify and rearrange them into different categories. So it becomes a documented information in this format. However, the original documents which this information was extracted from should also be saved on the database for future use. Should there be any manipulation of the information here, reference can be made to the original documented file. So having done that, we'll come to the section D, which is the merging of the information saved on the database with the individual objects of the BIM model. The management is achieved by connecting individual information that is being generated here to the individual objects in the BIM model. The construction information database is linked to the BIM model using the space-based categorization codes, which has been generated. Equally, the BIM model object allocated to each categorization code is stored on the database to ensure synchronization, such that we can use the objects on the BIM model to retrieve the information that was carried out to achieve that particular object, or we can use the object, the documented information to retrieve the objects of the BIM model. So once the BIM model and the construction information database are connected, construction information can be accumulated through each object of the BIM model, and it can be retrieved at any time for verification. For example, we have a wall member here. If it happens after construction that there's a crack forming on a wall, the construction information, the general construction information, and all other necessary information about this wall can be checked through the space breakdown structure. And then information breakdown structure and the work breakdown structure of the wall will give us the necessary details as shown in the next slide here. So, okay, we'll see here if there's a crack in the, on the wall. This would initiate a search on the database. So here we're searching for the space breakdown structure code of that particular wall model. Remember, individual wall members here would be appointed a particular ID code. So we can always search using the ID code of the individual members, or we can search using the work breakdown code. Take for instance, since it's a wall, let's say it's a concrete wall, then we can always go under the work breakdown structure for concrete. And once we are under the work breakdown structure for concrete, we'll get all the space information, the work information that was carried out, as well as the general information. So with this, we'll be able to say, oh, okay, we have concrete carried out on the wall at a particular date. What was the weather condition on that day? What was the temperature like? And then also we can have information like the laborers that carried out the construction activity and the supervisor that was on site for that particular day. So from this information that is being withdrawn or that is being retrieved, we'll be able to have a general knowledge of what transpired on the day the wall was constructed, what went wrong, and who is responsible for that particular crack in the wall. So basically, this ensures that information is managed adequately, and then it is retrievable at any point in time when the particular information is needed. So basically, what we have here is what the construction industry electronic document management systems are presently. However, what we have in this on the right-hand side shows the way it is going to be if we are incorporating a BIM-based information management system. So as it is, we have the beginning of document creation. Then this information is gathered, and then we create a document information for the information that is being generated. So there's a site document review at this point. If the document is accepted, it is moved on to the construction manager for review. But if the document is not acceptable, then it goes back to creating the document information. Also, at this point, if the construction manager is not accepting the document, then it goes back to creating the document information. So if it's acceptable, then we have a document information storage for it. and then we have the documenting storage, information storage on site. So here we have a copy with the author, then we have a particular copy on site also. But the problem is at the end of the construction process, this information are discarded, or okay, the author of the document might still have a copy. Most situations see that the construction site discard all this information, and this does not give room for usage of this information for future projects. So, but when the BIM information management system is being introduced, at this point we have a classification of document information, which is then stored on a database that is being generated through the categorized document information, as well as the electronic document itself, which can then be used after the project has been completed for future or subsequent projects. In conclusion, we'll realize that BIM's technology provides a new way to predict, control, and track product quality and quantity to improve material handling. This shows that the current method of document management is not based on storage in a consolidated database, but rather in individual storage or in a site document archive. As such, when personnel that has been working on a particular construction site are redeployed to another site after the work is completed, the documents managed by individual professionals are often dispersed, which therefore obstructs consolidation of construction information documents, while documents that are stored at the site are often not categorized, which reduces their usefulness and obstructs feedback for follow-up projects. So at the moment, construction management software already in existence can be integrated in the BIM 360 to widen the BIM potential in the construction environments in order to achieve construction information management. This will allow for information from different construction management software to be incorporated into just one software, just as we have seen with the Autodesk Forge. This will enable the formation of a system for gathering construction information by linking the structural and non-structural information. And then it is believed that this would help in accumulation of information for follow-up projects, and it will also aid in the accumulation of technical know-how by the construction organizations that are carrying out these construction projects. Thank you for your time, and that is the end of this presentation.